Good morning. Today we are reviewing linear equations. So remember, these are the three forms that we see on our formula sheet. We start normally with point-slope form, this one here. Then we usually solve for y. This is the form that you could graph it, slope-intercept form. And then if we want, we can get to standard form when we have x and y on the same side of the equals. So it says write an equation in standard form that passes through the given point. So just because it says we need standard form doesn't mean that's necessarily where we need to start. I know I have a slope of 4 over 5, and slope is usually my letter m, and my point is -3, -1. So I know this is my 1x and my 1y that I have. So if I have a point and a slope here, it might make sense to start with point-slope form. So I'm going to copy that down. Y minus y1 equals my slope, x minus x1. So I'm going to plug in what I know. Y minus y1 right here is -1. Those two negatives make a positive. Opposite of a negative is a positive. And then our m, or our slope over here, is 4 over 5. And then in parentheses, x minus x1, which is -3. Those two negatives again make a positive. So this isn't the form that we want, but we can take this now and solve for y, so then we can get the x and the y eventually down here on the same side. So I'm going to start by just simply solving. We can draw a box to distribute, to multiply. So 4/5 times x is 4/5 x. 4/5 times 3, I'm going to multiply that out over here. 4/5 times 3. Well, 3 is 3 over 1. So we have 4 times 3 is 12. 5 times 1 is 5. So we have 12 divided by 5. This isn't going to make a nice number. If you wanted to leave it in terms of a fraction, 5 goes into 12 2 times, and there'd be 2 pieces left over, so 2/5. Or if we plug that in our calculator, 2 2/5, or simply 12 divided by 5, would be 2.4, because 2/5 is 0.4, so we have 2.4. So plus 2.4. So I have y plus 1 equals 4/5 x plus 2.4. And then last, well not last, we need y by itself first. We're going to subtract 1. So those eliminate, and we have y equals 4/5 x. We have 2.4, we're taking away 1, we only have now 1.4. This is we're subtracting 1.0. And then we wanted standard form, so again, standard form is when we have x and y on the same side here. So right now they're on different sides, so let's move this x over to be with the y. So right now it's a positive 4/5 x, so I'm just going to subtract 4/5 x. So 4/5 minus 4/5 makes 0, so we have -4 over 5x plus y equal to 1.4. There's my answer in standard form. Next it says write an equation of a line with a slope of -4 and a y-intercept of 5. Write that in point-slope form. So I'm going to look back at my formula sheet. Oop, too far. Point-slope form is y minus y1 equals m, and then x minus x1. So I'm going to write that out up here, because that's what I need to plug in. And I do have this one already. I have m. Slope is my m is -4. I need an x and a y to plug in. And right now all I have is a y-intercept. But you guys, a y-intercept is where we would cross the y-axis. So it's a y-intercept of 5. 1, 2, 3, 4, 5. So that point right there, in terms of x and y, x, we didn't go anywhere negative or anywhere positive, so we went 0 left and right. And then we went up 1, 2, 3, 4, 5. So here is my x1 and my y1 that I can plug into my equation. So I have y minus y1, which is 5, equal to my slope, which I took from up here, -4, and then x minus x1, which is 0. And I'm done because I wrote it in point slope form. It did not say solve, it just said to write it, which we did. Next, write an equation of a line with the 2 points in standard form. So standard form, we want x and y on the same side. So down here, maybe you just put, we want x and y on the same side. So that's what we want to end up with. Right now we have 2 points. Well, in all of our forms, we need a slope somewhere. So I'm going to start with a slope. If you don't know how to find slope, here's our slope formula, y2 minus y1 over x2 minus x1. I'm copying it down. If you don't need to, that's fine. So here we have x, y first point, x, y second point, and I'm going to plug these numbers in. y2 minus y1, we have 7 minus y1, which is a -2. Those make a positive. Then on the bottom, x2, which is 5, right here, minus x1, which is 2. So 7 plus 2 is 9. 5 minus 2 is 3. Well, we can simplify this. 9 divided by 3 is just 3. So my slope is 3. Now, if I have a slope and a point, well, you guys, if I have a point and a slope, I can start with point slope form. So again, I'm going to write out point slope form and plug in what I know. So I have y minus, I'm going to use this first point. y1 is a -2, makes a positive, equal to our slope, which we found was 3, and then x minus x1, which is 2. So we eventually want x and y on the same side, so we better get rid of our parentheses first. We have 3 and then x minus 2. Well, 3 times x is 3x. 3 times -2 is -6. So we have y plus 2 equal to 3x minus 6. Now, we need this 2 over to be with the number, so all the numbers are together, so I'm going to subtract 2. And we have y equals 3x minus 8. Remember, same sign, add and keep. And then we need x and y on the same side, like it says here. So I'm going to move my x's, subtract them over to the other side. So we have a -3x plus y equal to -8. Oopsies, undo. So our answer, we have all the x's on the same side and the y's on the same side. And that is our answer. -3x plus y equal to a -8. Next it says write an equation in slope-intercept form. Slope-intercept form, again, I keep looking at my formula sheet, is this one here, y equals mx plus b. So I need an equation in the form y equals mx plus b. Well, I can find my m, or my slope, from 2 points. I'm just going to count rise over run. So I'm going to count 1, 2, 3. That's my rise, and I'm going to run 1, 2, 3, 4, 5, 6. Now I can simplify these both. I can divide both by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So my slope is 1/2. And then we need our b, or what we call our y-intercept. Where do we cross the y-axis? Well, this one just happens to be a nice number. Won't always be that case. So we have here, it's crossing the y-axis right here. This line crosses, which is at -1, -2, -3. So our b, we're crossing at a -3. So our equation should read y equals m, which is 1/2, x plus b, or in this case, minus b, because it's a negative. We went down instead of up. Next, it says write an equation in standard form. Well, we have 2 points. We can use what we know about those 2 points to first write an equation, maybe in point-slope form, because we have 2 points. So this point here, I'm going to find the slope between these two to begin with. I'm going to count rise over run. We're really going to go down -1, -2, -3, -4, and over 1, 2, 3, 4. -4 over 4 is really 1 over 1, or just -1. So some of you can see that this crosses again at a nice point right there. I know that this works because my slope is -1 over 1. If I went down 1 and 1 to the right, down 1 and 1 to the right, there's a nice point at each one. So the opposite of down and right would be up and left. Up and left. So I know for a fact there's a nice point there because we can just use our slope to go backwards. So that point we're at -1, -2. So my b, I'm beginning at -2 this time on my y-axis. So again, remember this is your y-axis. We began at down 2. So that's b. So we have m and b, so we can write an equation in this one like we did before, slope-intercept form. Y equals m, which is -1x, plus b, or in this case, minus b. This is not the form we want, though. That's slope-intercept form. We want standard form, which is x and y on the same side. So we simply need to move the x's over to the other side. So I'm going to add 1x. And we have 1x plus what? You can make that a 1y if you want, equal to a -2. And there we have standard form. The last one is probably one of the easier ones because it says we need point-slope form. Well, we can count our slope from the graph. Let's count rise over run. If you want to go up and left, you can. Just remember left is negative. Or we can go down and right, down being negative. Always rise over run, though. So I'm going to go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3. We can divide both of these by 3, and we get -2 over 3 divided by 3, which is 1. So really our slope is -2. And we need to pick a point. Doesn't matter which point you pick, but we need to write an equation. So the point that I'm going to pick, maybe I'll pick this point right here. So x first, I'm going to the left, -1, -2, -3, and then up just 1. If you want to use the other point, you can. So this is my x1 and my y1. Remember, point-slope form is just y minus y1, so we're not solving, just writing it in that form. So we're going to have y minus y1 equals our slope, x minus x1. So we have y minus y1, which is 1, equal to our slope, which is -2, and then x minus a -3. Those two negatives make a positive. And there's our answer. We wrote it in point-slope form. Next, we're going to take a quick look at line of best fit. Remember, slope of a line is the same as rate of change or this word correlation. They all mean the same thing. So it says, given the line of best fit, approximate the rate of change. Rate of change is a fancy word or term for slope. So they gave us a scatter plot, a bunch of points on here, and they need us to figure out which one is going to match here. So we need to pick 2 points that are on the line. So pick 2 points on the line that cross like at the corner of a street, right? We can't go through people's yards. I have to cross at the corner of 2 horizontal and vertical lines. So if we start down here and go up, right at the edge there, that's a nice point right there. This one's close, but doesn't go through the middle. Nope, nope. These ones aren't so good. Those are like cutting through people's yards. But what about way up here? Those are two nice points, so let's count our slope. Remember, m is slope. We're counting rise over run. So I'm going to count rise 1, 2, 3, 4, 5, 6. And run 1, 2, 3, 4, 5, 6, 7. Well, this is a nice slope. I used two good points, but none of those were the right answer. So I'm going to use my process of elimination and my handy-dandy calculator to eliminate some answers. So 6/7 as a decimal is a slope of about 0.85, or if we round it, 0.86. 86 hundredths. So if I type in these other ones, we need to figure out which one's going to be the closest to the slope I found. So first I'm going to start with 3/5. 3 divided by 5 is 0.6. Okay, not bad. Let's see if we can get any closer. 2 divided by 7 is going to give me 0.29 if I round. So right away that one's going to be out because it's not even close to 0.86. Then 5/4, 5 divided by 4, well there's 1.25, that's over 1. Probably not going to be that one. And then we have 7/8. 7 divided by 8. 0.875. If I rounded that, that would be 0.88, which is pretty close to 0.86. So I know that out of those two choices, D would be the best answer. Next, it says, what is the equation of the line of best fit? So I know this is a lot of work. It seems like a lot because we don't have any equations here for us. But generally, we simply want an equation in the form y equals mx plus b. So if we can find two nice points on the line to find a slope, we're halfway there. Well, this one's on the line, and there's a nice point for us. This one is a little bit off the line. This one, it's pretty close. If you want to use this point, I would say go ahead. But there's a point right here that goes perfectly through those two lines, x and y right there. So I'm going to find my slope first. I'm going to count rise over run. I'm really going down 1, 2, 3, 4, 5. So down 5. And over 1, 2, 3, 4. So my slope is -5/4. And then that's my M. Now I need to look for B. Because I used this point right here, I can use that because that is B. It's on the y-axis. If that point wasn't on the y-axis, we would have to use our point slope form and solve for y. But since it is, that's the point at 2. So B is 2. So my equation in the form y equals mx plus b is y equals -5/4 x plus b, which is 2. If we did this a different way, you guys, you would have used your point slope form and plugged in one of your points. So for example, if you use this point 4, -3, we would have plugged those numbers in to our equation. X minus our x1 would be 4. And you would have solved for y, and you would have gotten this same equation. I'm not going to go through all of that work, but know that there are multiple ways to solve the same equation. This next one, let's find two good points on the line. This one's not on the line, this one's not on the line, and neither are any of these. So we need to find our own 2 points on the line. If I start up here, I see a nice point right there. That point there is 3, 4, x, y. Remember, x is here, then y. And as I follow it down, what about right down here? 0, 0. That's a nice point. So my slope, let's count rise over run. I'm going to rise 1, 2, 3, 4. And run 1, 2, 3. Now this one again, you can see right away that b is 0 because it's crossing the y-axis at 0. However, I'm going to use this formula to show you an example of how to use it. Because we have points and a slope, we can use point-slope form. I'm going to use the point 0, 0 because it's easy to add 0 and subtract 0. So we have y minus y1, which is 0, equals our slope, which is 4/3, and then x minus x1, which is also 0. So parentheses means we distribute. We have 4/3 and x minus 0. So 4/3 times x is just 4/3 x. Anything times 0 is 0. So I have y minus nothing, which is really just y, we don't really need that minus 0, equals 4/3 x plus 0, which is exactly what we said b was over here. In the form y equals mx plus b, b is 0, because we begin on the y-axis at 0. Alright, this next one, we're actually going to skip this one, so don't worry about this slide. If you'd like to do this as a challenge, that will be a great idea. But I want you to take a look at this last question. It says, studies have shown that the more TV a person watches, the less sleep they get. The table below shows the number of hours of TV people watched in one day and the number of hours of sleep they got. So that just tells you what's below. So you don't really need anything in that paragraph. It says at 1 hour of TV, they sleep about 7 hours. So at 1 here, they put a dot at 7. So they actually plotted all of those for you already. They're already there. So all that they want you to see here is which of the following lines fits the data. Well, think, if I was going to walk across this line, would I be going up or down? As I move across, I'd be going downhill, so I know my slope is negative. All of our equations are in the form y equals mx plus b. So my m has to be a negative number. Well, this m is not negative, so it can't be that one. This one's not negative, can't be that one. So it's got to be either c or d. Now, b is where we begin on my y-axis. So here's our y-axis. Where do we begin at? Well, we begin way up here. Our graph or our line starts at a positive 8. So as you can see, plus 8, that's an option. So we can eliminate D, and our answer must be C. That is it for today. You have 3 questions here. You have to take through the different forms to get to the form that you need. Be careful, it says write in point slope form. So this one, you don't need to take through these next 2 steps. You only need to do the first part here. This one says write in standard form, so you need to take it through all 3 steps. And this one says slope intercept form, so you need to get to the middle. You don't need to get to standard form. These ones, write the equation in the form that they say. And then on the back, looking at slope, or writing an equation just like we did right here. If you have any questions, please let me know.